Hello and welcome to my first YouTube video. I'm Yuna, a Java developer and also a teacher at the Hacker School for Kids. Today I want to show you an easy way to start with Tinkerforge. Tinkerforge is a really good open source IoT manufacturer. You can simply focus on your project without taking care of the hardware, tools, programming language or operating system. That's why I created a Java library on top of it to provide the same simplicity for the API usage. So how to get started? Before you can start, you obviously need a working Tinkerforge setup. Means Tinkerforge hardware with requirement software, Java, and an editor for coding. Just write me in the comments if you need help to get started and what you are missing. With the help of your feedback, I can improve my library description, and if required, I can make also a video out of it. And here we go now. As you can see, I created a simple setup with a master brick to connect the sensor with my computer, a distance sensor to measure the distance, a segment display to show the distance value, and a RGB button to additionally trigger something which comes in my mind. For coding, I'm using IntelliJ from JetBrains, which can also install Java for you if required. In order to use the Tinkerforge sensor library, you need to edit a new class path. So after having done this, we can finally start with our coding. As you can see, my code looks like everyone else's starter code with a public static main method, which is where the program starts. And we will start by defining the stack. Going here, defining my variable stack, like static stack, and here's the name of it. We call it stack, obviously, and then we just create the new stack object. To connect the stack, you simply write connect just behind of it. For our test purpose, I will just add one more line here, which is basically now saying I'm ending the program when a key is pressed. Now we can have a look what happens. So first I'm connecting now the stack with the computer via the USB. You can't see that, but the LEDs are blinking. That means everything is ready now. And now I will just start our program and see what happens. As you could see, the sensors and the stack is reacting to that code now. The RGB button was showing some colors, and also the segment display was showing some numbers. That's a good sign, because that means we are connected to the whole stack and all sensors connected to it, just by simply writing connect. But what can we do now? Of course, we can do more than just connect to the stack. We can also now use the whole stack and so for the first test, I will just write something on the segment display. So I go to our stack variable, like that, stack, and I'm asking to get some sensors, and to get more precise, I'm saying I want the segment display. If you have more, you can add also an index. The sensors are sorted by the connected port, but in our case it's fine, we just have one, so take the first one. And then we are sending a message, like hello, and see what happens. For that I'm just restarting now. And now hell is written. Of course, the O got cut because we have only space for 4 characters. And now I can do the same with the RGB button. For that, I'm doing the same again. Stack, get RGB button, or button RGB, it's called here. And then I will send a color. A color can be a number, or you can just use a color object like color.red. And now I will restart and see what's happening. So my button is red. So I think it's pretty clear how to access the sensors. But how can we react to a sensor output like the distance sensor? Let's say now I want to display the number of the distance value to the segment display. For that, you can add a listener to the stack, like this, stack dot add listener. And then you need to listen on a sensor event, because each sensor can trigger an event. For a better overview, I will just create now a separate handler method, which is handling the sensor event. So we write private static on sensor event, which is consuming the parameter sensor event. I call it event. And of course, it's not returning anything, so we don't need that. And now we can simply add our handler method to the listener. Oh, I just have a typo. It's not even, it's event. So let's rename it event. And now we want to react on the distance. So I write, if the event is the type distance, like this, then we want to write the distance on the display. As we remember, we can simply access the display by using the stack, like stack get and writing the display segment again, and we are sending now the event value, because the value is distance. So what will happen now? Let's have a look. So at first everything is the same as usual, but nothing is happening, because the distance sensor doesn't send anything yet. In order to receive a value from the distance sensor, we have to change the distance. For that, I'm holding just the hand over it, and you can see numbers now coming on the display. That was pretty fast. We just connected two sensors together. And now we can also use the RGB button also. And we are sending a color to it. I will now use the predefined rainbow color, like this, color dot rainbow, which is a range of colors. So we have to identify the index which color of the rainbow we want to have. For this, I will use some math, like event dot get value, the distance value, minus 200, because I know my distance sensor is starting from 200 millimeters, putting it into brackets, and then multiply it by 2.17. Oh wait, I want to divide it, because I don't have endless colors in the rainbow. So now let's see how that will look like. I will just restart again everything, and now I will change the value by holding my hand over the sensor. And now we are starting with a green. And you can't see my hand now going up, but you can see the values. And as I go higher with my hand, you can see that the green is going to yellow now. And after yellow, let's see what it comes. It goes to orange, orangey, yes, red, purple, everything is there, blue. So with some math, we even can animate our RGB button. Now I want to turn off all status LEDs of the board while pressing the button. That's also pretty simple. Now we do an else if. If it's not a distance, then we check if the event is a type of button pressed or button released, doesn't matter so much here. And then we want to call all sensors in the stack, like get sensors, but only the sensors with a status LED. As you can see, not everyone has it. So only status LED sensors, like this. And then for each, we will apply sensor.status LED off. And now we can check what's happening and if it's working. Restarting everything and pressing the button should turn off now the status LEDs. And status LEDs are turned off. For the last exercise, I want to turn off and on again the status LED. For that, I will define a second variable which holding the state of the status LED. So I define static boolean LED toggle, and I also can put some value directly in it. Now we have an enum for the LED status, so if the LED toggle is true, like this, then we set the status LED to the type LED on. We can replace it by static import, looks more beautiful, else the LED will be just off. And what we are missing, we have to invert the toggle from true to false, from false to true each time we are pressing the button. For that, we are saying LED toggle is the inverted LED toggle. And now we can just restart and see what's happening. So pressing the first time turns the LED toggle on, and the second time turns it off. And I can do that all the time. On, off, on, off. I hope you could enjoy my video, even it was my first attempt in doing this. Now I need your input, obviously, to improve myself. Like and follow for more. See you, Yuna.